We are alive. Okay, solving, we're going to talk about solving and graphing inequalities in slope-intercept form. And this is a natural step from yesterday, what we did yesterday about about graphing equations, right? Those were equations. The difference now is we're going to look at inequalities. You guys all know this? Greater than, less than, greater than or equal to, less than or equal to, right? You know what they are? So this is less than, right? This is less than or equal to, less than or equal to. I think you all know this, right? Greater than, and greater than or equal to. So if it has that line, it means or equal to, right? Greater than or equal to. Okay? You guys all remember this, right? So if I give you an equation, well, yeah. So yeah, let's see. So if I give you an equation that it's not an equation, excuse me. If I give you an inequality, so it's like an equation. Why don't you move up so you can take notes? Read to me what it says.
The first one says.
Yeah, why don't you sit up here, okay? When you squinted, I knew immediately. Okay.
Gary knows this. He has glasses.
Yes, I'm very aware of what it's like without glasses. I would have been. Excuse me, teacher. I can't see. Yeah. So get in the habit of taking notes because this is some of this is new. It's not like you didn't take notes yesterday. You said because you knew it all, right? But the last two you didn't do right.
Yeah, because
because you didn't take notes, dude. Take notes, okay? Seriously, use your notes. In high school, I guarantee you, there is no way you're going to pass a math course if you don't take notes. I promise you. So you've got to get used to it. It's complicated stuff, some of the stuff they do. So the notes are like gold for you, right? Really important. But this part you know. You don't have to write this down. I assume you know this part. But I'm just sort of making sure everybody's on the same page. Now, what if I did, okay, there's two kinds of things. First of all, if let's see here. Yeah, what if I said this? Tell if the ordered pair, so write this down, ordered pair. So be sure to write that title down too, right? Tell if the ordered pair is a solution to the inequality. Okay, so those are the directions. Now I'm going to give you an ordered pair, say 4, 10. And I'm going to say, here's the equation, or the inequality. Y is greater than 2x plus 4. Okay? Now what would I do? What does it mean when it says, tell if the ordered pair is a solution to the inequality? What does it mean to be a solution to an inequality? Yeah.
No, I was going to say that answer that. Well, what if you do two graphs and you chart which one they think?
Totally, you could totally graph. That's one way. But what I'm going to suggest is right now, let's just think of it algebraically, okay? We're going to do the graphing in just a second, but I just want to think about it algebraically for a second. What does it mean that this ordered pair is a solution to the inequality? What would have to be true if this has a y in it and an x in it, two unknowns, right? You good with me? Right? Two unknowns. But did I give you an x and a y? Right here, right? So this is my x, and the 4 is my x, and the 10 is my y. Right? And so in order to know whether this ordered pair is a solution to this inequality, what I have to do is replace the x here with the 4. Just substitute these numbers into the equation, or into the inequality, right? Make sense? So I'm going to just do that. So 10 is my y. So I have 10 is greater than 2 times x is 4 plus 4. You with me so far?
Yeah.
All right, so 10 is greater than 2 times 4 is 8 plus 4. So 10 is greater than 12. What do you think?
Easy.
So what's the answer?
10 greater than 12.
Is that true?
No, false.
Oh, so that 4. Oh, I get it. So
Don't,
it's
wait,
the
don't
left.
you write an F?
What do you think? Do you think he's right? Is this true? Is this a true statement? 10 is greater than 12.
No.
No.
Absolutely not. This is totally not true. That is not true. Therefore, this ordered pair is not a solution to that inequality. Does that make sense? If it is untrue, if that's an untruth, this is an untruth. That is false, right? That is false. There's no way 10 is greater than 12. Not in my universe. Therefore, that 410 is not a solution. So I would say not a solution.
That's the answer, not a solution.
Yeah.
And if it is a solution?
And if it is, then this would be a true statement. So if it came out like, let's say if I said another problem. Let's say I said 20, right? If I had 20 there. And instead of 10, it said 20. 20 is greater than 12, is that true?
Yeah.
Yeah, then I would say, oh yeah, that's true. Yes, it is a solution. That point, that ordered pair is a solution. You see the difference? So all you're doing is plugging these into the inequality, and then you're deciding, right? Okay.
When would this be used? And why is this relevant to what?
Because you're going to get problems like this a lot, like on SATs and pre-SATs, where tell if the ordered pair is a solution to an equation or an inequality. You need to know how to do that. You need to understand how to do it. You also have to understand why. And then eventually it's useful in word problems, but I don't want to go in. I only have 5 minutes to finish the lecture, so I don't want to go into an example of a word problem, but I will eventually. Okay? But it is actually useful. Quite useful. All right. So now we're going to talk about graphing, because the homework is just 2 things. It has this kind of stuff, where you just have to replace it and decide if it's true. And if it's true, it's a solution. If it's not true, it's not a solution, right? And then the other part is graphing inequalities. But they're going to be in slope-intercept form, so it's the same method that you've been using last night, that you used last night on your homework. Only those were equations, right? So it was a straight line, and it was a straight solid line. With inequalities, I don't know if you guys did this with Nate or not last year, did you? Did you graph inequalities? With dotted lines and solid lines
Oh, yeah,
and
we did.
shading on one side of the line or the other. So it'll be a review, but let's say I asked you to graph y is less than or equal to 1/2 x minus 7. Okay, so write that down. Okay, y is less than or equal to 1/2 x minus 7. So I'm going to draw my graph. And I know immediately I've got to go down -7, right? 1, 2, 3, 4, 5, 6, 7. And I'm going to put a dot there. Now, what do I do now?
Rise 1 and run 2.
Rise 1, run 2. So about there, right? Somewhere in there. And then I'll do it one more. Rise 1, run 2. Boom. So it's right there. Okay. Now, I'm ready to draw my line. But when it's an inequality, see this inequality here? When it's an inequality, the key is knowing what kind of a line to draw. This says it's less than the line, but it's also equal to the line.
So it's gonna be a solid line.
It's going to be a solid line because, remember, you already know how to do them when they're equal, right? Y equals this, you would just draw a solid line, right?
Maybe a dotted line.
So as long as it says it has an equal in it, then it's going to be a solid line. So that says less than or equal to. The equal means it's going to be a solid line. So I just draw a solid line. There's my solid line, very poorly done. All right? But that's it, you got the idea. Now the thing is, am I done?
No, no.
I have to decide which side of this line to shade. Remember how to do that? This is where everybody needs to pay attention because you're not gonna know how to do the homework if you don't. Okay? What do I choose? I'm gonna choose a point, right? Yes, Lucas.
Is 0 greater or less than 1/2?
Almost. I'm gonna choose an easy point on the graph. Right? What's the easiest point on the planet, on the graph?
1, 1.
Well, that's pretty easy. There's an even easier one.
0.
0, 0, right here at the origin, right?
Yeah.
That's a really easy point. That's 0, 0. So that means x is 0 and y is 0. So I'm going to see if that is a solution. This is an example of like what we just did a few minutes ago algebraically. I'm going to see if this point is a solution to this graph, to this inequality. If it is, then every point on this side of the line is a solution. Does that make sense? If it is not, that means no points on this side of the line are a solution. I have to jump to the other side of the line, and all these points are a solution, and then I would shade that way. So I have to decide, is that a solution to this? So I'm going to do this. I'm going to do, instead of y, I'm going to put a 0. I'm going to just write it like this. 0 is less than or equal to 1/2 times 0 minus 7. Well, what's 1/2 times 0? 0. So I don't even need that. So 0 is less than or equal to -7. Is that true or false?
False.
That is false, right?
So it's gonna go away.
So it's not, this is not a solution. That means there is no point on this side of the line that's a solution. So I jump to the other side of the line and I shade this way. You guys remember this a little bit?
Yeah.
I shade that way. Now I have to do one more problem before that doggone bell rings, which is about to ring right now. Can I move? Can I move forward? Can I erase this? All right. I'm going to keep my graph though, because I need to save time. All right. Now we're going to say graph y is greater than, we'll say 2x minus 3. All right. So we're just going to quickly go down to 3, and 1, 2, 3, put a dot. My slope, Max, did you know how to do this? You turn that into a fraction so that you have a rise over run. When you have a number that doesn't have a fraction, make it a fraction, right? So I'm going to rise 2 and run 1, okay? So I'm going to rise 2, run 1, put a dot, okay? And then rise 2, run 1, put a dot, and I'm going to draw my line. Now the question though is, before you draw your line, you always have to ask, is it going to be a solid line? Meaning, does it equal, does it have an equal sign in here?
No, it's going to be dotted.
Or is it dotted? It doesn't have that equal line. Do you see what I mean? It doesn't say greater than or equal. It just says greater than. Therefore, it cannot be a solid line. It does not equal that line. So that line becomes what's called a boundary line. That's all it is. I know that anything on this line is not a solution. Does that make sense to you? It is not a solution. It would only be a solution on that line if it said equals. So because it doesn't say equals, I've got to make it dotted. And then I just do the same thing all over again. I decide, well, which side do I shade? And so I look at 0, 0. And so I'm going to plug that in. So I've got 0 is greater than, this is going to be 0, right? minus 3. Is 0 greater than minus 3? Yes or no?
It's, yes.
0 is greater than minus 3. Therefore, that is true.
Shit.
That means everything on this side of the line is true. So I'm going to just shade this way.
Right, question. You
Yes.
had, like, the line going straight down the middle, like y equals x. Which side would you shade?
Oh, very great question. I wonder if I put that on the homework. Hang on a second. Ooh, yeah, I did.
You did?
There's one, yeah,
What do you
very
do?
good question. So he asked a great question. What if I gave you y is equal to x? Thank God that bell's not ringing. Okay, y is equal to x. Think about it. Y equals mx plus b. What's my b?
0.
0 plus 0. And what's my slope?
1.
1 over 1, right? So I'm going to put my dot on the origin, right? Because my b is 0. Whoops. Right? And then I rise 1, run 1. So rise 1, run 1, put a dot. Rise 1, run 1, put a dot. And so yes, oh, not equal, sorry. We'll say less than. All right, so y is less than that, okay? So is it going to be a solid line or a dotted line?
Dotted.
You see why? Does that make sense? It doesn't say equal, so it's got to be dotted.
But which way would you shade?
So Luca identified a very, very important point. That if the line goes through 0, you can't use that method, right? You can't use the 0, 0 as your point because that 0, 0 isn't on either side of the line, it's on the line. So you have to choose a point that's not on the line. So then you might look at his brilliant idea. He said 1, 1. We could try 1, 1. Look, 1, 1. Oh shoot, 1, 1's on the line too.
1, 2.
We could do 1, 2. Right? That's fine. Let's do 1, 2. So we will go this. We'll say 1, 2. We're going to try 1, 2, which is right here. 1, 2. So we've got y is 2. So 2 is less than 1 times 1 is 1 plus 0. 2 is less than 1. That's false. Therefore, this is not a solution on this side, right? So you would shade to the other side. You can choose any point. I could have chosen this point down here. I could have chosen this point here. I could try any point I want. But if you keep them smaller numbers, they're sometimes easier.
Right.
A lot of times what I'll do is I'll choose something on one of the axes. Like this would be, say, 0, 4. At least I know my x's are 0. See what I mean? So I would have said 4 is less than 0 plus 0. 4 is less than 0. That's false. It's not going to be here. See what I'm saying? It doesn't matter. You can choose any point over here, and then you just shade the other direction if that's the case. You get it? You get it, Oliver?
Yeah.
Awesome. Everybody, fist to 5? We rock, guys. Okay, beautiful. All right, so that's it.